This is the PD blocker. It's a power delivery firewall. It protects your USB-C devices from high voltages and attacks over power delivery. Thanks to power delivery, it is now easy to charge rapidly your phone. You can even charge laptops using the same USB-C connector. Feeding it 60 watts or 100 watts is no issue anymore. And USB devices more and more adopt this USB-C connector. To reach such power levels, it must raise the voltage to 20 volts. But most devices use USB only for data transfer and just require 5 volts. They don't need power delivery and actually don't support the higher voltages. Normally this is not an issue, as higher voltages are only delivered upon request. But smart chargers might have bugs and be stuck at a high voltage. And if you plug in your expensive device and it gets fried, you won't be happy. USB-C cables can also be electronically marked using a chip. This is even required for 5 amps 100 watts charging. Normally the e-marker is only used to know if the cable is 5 amps capable, but the chip embedded in the cable speaks power delivery, and nothing prevents a malicious cable from actually raising the voltage at any point. Here I use an external power delivery trigger for the demo, but the cable could do the same. And this is where the PD blocker can save your day. Just plug it in your charger or device, and any high voltages will be blocked. Power delivery is a complex protocol and often implemented in simple embedded microcontroller stacks. This increases the attack surface of your computer or mobile phone, and it's only a question of time until it is exploited, if this is not already part of some agency toolset. The PD blocker also acts as a firewall and prevents all power delivery communication. This works no matter where you insert the PD blocker in the chain and would even prevent malicious USB-C cables from increasing the voltage. The PD blocker only blocks power delivery. USB remains unaffected and you can still use USB 3. How does the power delivery blocker work? Well, for that let's have a look at the schematic. Now here we have the two USB-C connectors, the plug and the receptacle. All data lines are connected through. This allows you to have USB 2, USB 3 communication unaffected. What is not connected are the two V-bus lines. They go through two P-channel MOSFETs. And by default, these are switched off, which blocks current from going from one side to the other side. Here we have two comparators and they compare the voltage, which is provided on one side and the other side, to 5.5 volts. This is a reference which is provided by this small LDO. And if it's below 5.5 volts, then the P-channel MOSFETs are enabled and allow current to pass from one side to another. Now, if it's above, then it will just cut the power by switching off the P-channel MOSFET. Here we have two additional comparators. They do the same comparisons, but they are just here to indicate which side is the culprit and which side has a voltage. This is why we have two red LEDs there. So this is to block the overvoltage or to protect from overvoltage. Now, to do the power delivery firewall, we have two small capacitors on the CC lines. Although power delivery just uses one CC line, you never know which one it is because USB-C is reversible. So we need to put capacitors on both of them. And it's not allowed, or I didn't cut the CC lines through because CC lines are used to identify or to detect when something is plugged in and to figure out which orientation it is in. This is why we cannot cut it through, but by adding the small capacitors, we smooth out the signal and simply block any power delivery communication. And because this design is open source, you can download the schematic and the fabrication output of all versions. These are all the versions. Version 0 used a Zener diode as voltage reference, but this got way too hot at high voltages. With version 1, I used a quad op-amp to also indicate which side was causing an overvoltage protection. And it uses a more efficient LDO as voltage reference. Version 2 is the same, just production ready. And if you want to know which version you have, just look at the marking on the bottom. There you can also find a QR code which points to the manual and all the source files. And to test the device, I first connect it to 5 volt to see if this goes through. Then I use a higher voltage and ensure that it blocks. And I also do it in the other direction. And finally, I use a USB 3 device to be sure that the USB data lines work perfectly. And with that, the PD blocker is fully functional and ready to be shipped. Enjoy!